Task number 2, importance of cryptography. Cryptography's ultimate purpose is to ensure secure communication in the presence of adversaries. The term secure includes confidentiality and integrity of the communicated data. Cryptography can be defined as the practice and study of techniques for secure communication and data protection where we expect the presence of adversaries and third parties. In other words, these adversaries should not be able to disclose or alter the contents of the messages. Cryptography is used to protect confidentiality, integrity, and authenticity, the triad. In this age, you can use cryptography daily, and you are almost certainly reading this over an encrypted connection. Consider the following scenarios where you would use cryptography. When you log in to try Hack Me, your credentials are encrypted and sent to the server so that no one can retrieve them by snooping on your connection. When you connect over SSH, your SSH client and the server establishes an encrypted tunnel so no one can eavesdrop on your session. When you conduct online banking, your browser checks the remote server certificate to continue that you are communicating with your bank server and not an attacker's. When you download a file, how do you check if it was downloaded correctly? Cryptography provides a solution through hash functions to confirm that your file is identical to the original one. As you can see, you rarely have to interact directly with cryptography, but its solutions and implications are everywhere in the digital world. Consider the case where a company wants to handle credit card information and process related transactions. When handling credit cards, the company must follow and enforce the Payment Card Industry Data Security Standard, PCI DSS. In this case, the PCI DSS ensures a minimum level of security to store, process, and transmit data related to card credits. If you check the PCI DSS for large organizations, you will learn that the data should be encrypted both while being stored at rest and while being transmitted, which is in motion. These are two terms that are used: data that is at rest and data that is in motion. Data at rest is basically DB, and data in motion is basically data that travels in emails, in code, in requests and stuff like that. In the same way that handling payment card details requires complying with PCI DSS, handling medical records require complying with their respective standard. Unlike credit card, the standard for handling medical records vary from country to country. Example laws for regulations that should be considered when handling medical data records include HIPAA, Health Insurance Portability and Accountability Act, and HITECH, Health Information Technology for Economic and Clinical Health in the USA. GDPR is in Europe. Basically comes from General Data Protection Regulation in EU. DPA, Data Protection Act in UK. Although the list is not exhaustive, it gives an idea about the legal requirements that healthcare providers should consider depending on their countries. These laws and regulations show that cryptography is a necessity that should be present, yet usually hidden from direct user access. Answer the questions below. What is the standard required for handling credit and card payments? You can see it over here. It's PCI DSS. PCI DSS. Payment Card Industry Data Security Standard. Cool.